The topic that I'm going to present today is the unusual magnetic and electronic properties of the L-substituted full isotope alloy geotomin in. Full isotope alloys are predominantly ferromagnetic materials, and they have possible practical application as safe memory alloys. After the discovery of geotomin Ni by Berman's group, various groups tried to pursue this material because in geotomin Ni, instead of the A site is occupied by the sp element, it shows a large ferromagnetic behavior. So we thought it might be interesting to study the effect of A substitution at the Ga site of Ga2-Ni. So the question that we ask here, does this replacement lead to an energically stable structure or not? And if so, then what is the ground state magnetic configuration of this such system? So for this, we have taken a Ga2-X ALX Ni kind of system, and the formation energies are calculated using VNAV initial simulation package, whereas the magnetic properties are calculated using SPRKK program. And in both the cases, we have used the exchange coordination PV as an exchange coordination function. From the table, we listed down the magnetic and electronic properties of such system, and as we can see, as we go from Ga to Ni to Al to Ni system, the magnetic moment of the system get reduce significantly. And as imine atom is the main moment carrying atom in the system, as you go from G2 to L2 system, the moment of the imine atom basically quenches. To understand this, we have plotted down the charge density of Ga2 and Al2 system. And as you can see, around the imine atom, there is a large amount of charge accumulation for Al2 system. And the Burdett charge analysis shows that there is a large amount of charge transfer from the Al atom to the imine atom in the Al2 system, which is also matching with the density of stress analysis of the imine atom. As you can see, as we go from x equals 0 to 2, that is from Ga to MNNI to Al to in a system, the minority states and as also the majority states shifted towards the Fermi energy, and hence the exchange splitting between these two get reduced, and hence the moment get quenched. And further, we found that the imine interaction to be RKK white, indirect RKK white. And another interesting result we show that for the AL2 case, there is a large density of states around the Fermi level. So we conjecture that there might be a the large density of states at the Fermi level if we partially doped a hole in the system. So we have doped 50% of the Ni sites with the cobalt atom and found that there is a high density of states at the Fermi level for minority spin channel, and which shows a Van Hoff singlet kind of feature in the density of states. This is further verified by plotting the block spectral function for this kind of disorder system. And as we can see in the Fermi energy, there is a flat band kind of features for most of the high symmetry points. So on conclusion, I want to say that using density functional theory based calculation, we predict a new Heusler Al2 and its quenching of magnetic moment is being understood from the charge difference density plot as well as from the partial density of stress plots. And further, partial hole doping at the Ni sites leads to a large density of states, Van Hoff kind of singularity kind of features at the Fermi level, which is also verified by the block spectral function.